Hello, it's James from XRobots.co.uk. This is part 20 of Hulkbuster. We've had 20 episodes already. Don't forget to watch the previous ones to find out how it works. Basically, I've got this giant suit that's a frame with lockable joints that stands there by itself. I can climb in, walk around by unlocking all the joints, then I can lock them all up again and climb out and leave it standing there. The idea is we've got various panels and things that open up for show and also to let me get in and out along the back. And the arms are mechatronic from the elbow down, so I've got joysticks in the upper arm which control the arms and the hands. So I'm working my way through putting the panels on. Last time we started to work on the helmet, which is going to be quite a big feature of the suit. And this time we're going to try and work out those panels. So the suit is inspired by the Iron Man Hulkbuster in the Age of Ultron film, which comes out next year. Obviously the trailer's been released. The one I've built I started way before that, so no one knew what it looked like, so we didn't quite know how similar it was going to be. It's not totally the same, but the helmet is going to be quite inspired by the trailer, but obviously with a bit of my own creative spin on. So let's go and look at that mechanism again. So I'm right up by the ceiling again, and what we had last time was this removable mechanism that comes off completely, so that we can take it off for transport. And also my ceiling's not tall enough, so I'm going to need to keep this separately until I can put this somewhere I can use it. Now basically what we've got are these two pieces that swivel round for the sides, so the helmet can open. We've got a piece that swivels up here, which is going to bring up the top of the helmet, which will then probably hinge down. That's going to be... obviously all these are going to be motorised so that it travels up and down, and then we've got a big gap in the front of the suit to bring the faceplate out. So basically all of those four sections come round and meet. But in order to actually design any more mechanics and get the angles right so all the pieces line up, as I say, I need to actually make the pieces. So how am I going to do it? A lot of the previous panels were made of lightweight material like foam PVC board, various other things with 3D printed formers and brackets on. However, the helmet I don't really want to build by hand. It's going to be quite a central feature of the suit. So I'd like to actually draw that up in CAD and 3D print it so we can get lots of details on it. That is going to make it slightly heavier, although we can print with a very low density infill so the parts aren't solid. So I'm hoping we'll get away with maybe just over 1 kilogram for the entire helmet. Now I put R2-D2's head up there in the last episode, and that was quite big and almost the right size, but I think Hulkbuster's helmet needs to be quite bigger. Traditionally it's a shallow dome, but I still need to leave the height to get to the top of that mechanism so that my actual head fits in there. So considering that, I think it needs to be around 0.5 metre in diameter. So let's have a look at some CAD that I've been working on. So here's the design that I've been working on. Here's the helmet, which is going to be on the suit. I've designed this in Autodesk 123D Design, which is free software, which you can download for absolutely nothing, although it isn't open source. So the size of this thing is basically 0.5 metre across, so 500mm in diameter, so fairly large. It's pretty much 1/4 of a hemisphere. So it's not quite as flat as some of the Hulkbuster helmets, but obviously, as I mentioned, I need to get my head in there. And that's also on top of a 50mm ring, so the rim around the bottom gives it another 50mm of height, although it doesn't really affect the contour of the hemisphere. So there's some recesses, the ones around the bottom there of the helmet on that rim, which have extra parts that need to be added in, which is kind of inspired by the Age of Ultron trailer helmet. So altogether it's got a similar appearance. It's not quite the same as the one in the trailer. So I looked at it a couple of times, then drew what I thought basically. It's kind of got the ears, which are fairly similar. Although I've had to be careful with the overhangs so it can be printed. So the bottom of the ear here, that angle is just over 45 degrees, but I'm pretty sure it's going to print okay. And similarly the chamfers in the bottom of those features either side around the jaw should print okay. I should be able to print those overhangs without support material. So obviously there's several things here. We need to cut this up anyway so that the parts can hinge in their 4 sections, and also I need to cut this up so I can get the prints on the bed. It's slightly higher than the TAS will print, and obviously as we come over to the centre of the head, that's too much of an overhang to print, and that top of the head needs to be a separate segment anyway, which reels in on that curved track I showed you. Here's the version I've split up. So these are the 4 sections. So obviously the silver part is the top of the head that wheels in, and the green parts are the 2 sides of the faces. I should add that it won't be this colour. Of course, it's going to be finished off and painted in red and gold appropriately. This is just to show you the divides in it. So, and obviously the faceplate will be that separate piece as well, which is going to be the first piece that I'll print. So obviously that piece comes out. So that piece will be printed in 1 piece. The top of the head I'll likely cut into 2, and the sides of the head are too tall to fit on the printer. So, and the overhang is probably a bit sharp as well. So we need another version that's cut down further into pieces for printing. Here's my print version. I've cut the top of the helmet again into 2 parts, and I've chopped the top of the ears off on each side, so I can print those as separate parts. So that gives us 7 pieces in fact to print, 4 for the top of the head and 3 for the bottom. And this is quite big. As I said, it's 1/2 metre across, so I don't want it to be too heavy. The sections are quite thick once they're printed, but of course we can print these in a lower density infill, so I'm going to start with 30% with a faceplate, and we'll see how much that weighs when we've done it, and then based on that I may go down to 10% for the other parts. But obviously I need some structural integrity, and I want it to look like proper armour when it opens and closes ultimately. So let's print off the first part and see how that goes. So I've just kicked off the prints. We're printing in PLA, so the base here is blue painter's tape, which is just blue masking tape. The bed is totally cold. We're not using any heated bed. We're extruding about 220 degrees. It's just doing the very, very first layer, so we'll come back in a bit and see how that's doing. So we're 27 minutes in. Getting there. Hopefully you can see that it's doing it's about a 30% rectilinear infill, so it's a crisscross pattern inside, and it's actually building up the piece relatively quickly. So we are 2 hours 37 in, and we've just got past the main block at the bottom there, and it's just working its way up to do the faceplate detail. So far this is looking pretty good. Let's zoom in. We've got no splitting or cracking or anything. This has all stayed together, mainly because of the PLA not shrinking really very much at all as it's printing and cooling. So that's really, really good. Still stuck to the bed fine. So it's about just under 1/3 of the way through, according to the little dial on the printer, which is this one here. So it looks like it's going to be probably over 7 hours, I'd have thought. We'll come back in a few more hours and see how it's doing. So we're 4 hours 19 into the print. It's going pretty well, as you can see. There's no sign of warping. There's a slight bit, it's come slightly unstuck down there, but hardly at all. So not nearly as bad as ABS, and the part is still in 1 piece, and it's all looking like it's going to be fine. So we're on 6 hours 30. And we're nearly there, so it's just doing the very top piece between the eyes and pointing up the sides. So it looks like it's going to be just under 7 hours in total. And here it is. So there we go. That's all come out perfectly fine. It looks pretty good. Not really any defects worth speaking of. It's pretty weighty though. I think 30% was a little bit too dense. So I'm going to do the next parts in 10%. It took about 7 hours though, so I may get nothing much else done in this episode apart from printing this helmet off. So obviously the other bits are far bigger. I'm printing this part in only 10% infill. So far we're 1 hour and 7 minutes in. So it looks like another really long print, but it's building up a lot quicker this time. So if I zoom in, you'll be able to see that the infill is really quite sparse on this one. And here it is. So that took 9 hours to print. Obviously it's quite a bit bigger, so I got quite a bit extra out for the extra 2 hours or so. And so obviously that piece will line up, and we need to do the other side. So there's only one small defect in this piece, which is just here, where you can see something nasty has happened to the edge. So I basically didn't consider that overhang enough. There are quite harsh overhangs here, which are almost practically horizontal, which have come out fine. There's quite a lot to stick the next layer to on each time. I hadn't considered in the design here that this rim down here is actually really thin. So the problem is when it's done the overhang, there's hardly anything to stick it to. So something quite weird has happened. Now I can sort that out with a file and a bit of filler. This whole thing is going to get coated, which I'll talk about at the end. So the main problem here was I've turned up the speed to try and make these parts print quicker, and that's what's caused this issue here, I think. So there's a handy knob on the TAS I can just turn down. So when I come to do the other side, when it gets to this level, I can just turn the print down to about 60%, and hopefully everything should be okay. So let's have a look at that. So this is the other side. We're 2 hours 25 in. It's just going very slowly there to do the top of the top surface up on top of the infill, which it always does really slow, and there's 4 layers on top of there. Then it's going to start building up the next part, and then we can turn the speed down. So we're getting there. It's just building up, starting to build up that part above the very bottom rim there. So all we need to do is turn this knob down. There's a little thing here that says FR, which is feed rate. It currently says 100%. If I just turn this down, you should be able to hear the printer slowing down, all the way down. Just going to do to 60%. Now it's going quite a bit slower, and I'll see how that starts forming and maybe turn it down a bit more if anything goes wrong. Similarly, you can turn that right up as high as you like to make the prints quicker, although obviously the print quality isn't quite as good. And with the acceleration settings for short moves, it won't actually get up to speed. So it has a limited effect, although if you've only got an hour left at an exhibition and you want to finish that print, just turn the knob up to 200% and hopefully you can get it out before the end of the day. So here is the equivalent piece, which so far is okay. I don't know if you can see there's a bit of curl on it. Try and get some focus. I turn the printer right down to 50%. Obviously once I've got past this I'll turn it up. So far it's looking not too bad. There's a bit of mess on the very point. Hopefully we should be okay, so we'll check on that in a few more minutes. So everything's absolutely fine with that, going a bit slower, so now I'm just going to turn the speed back up to complete. So we'll just turn that back up to 100. Off it goes, back to full speed. So here are all my parts. Obviously this thing's absolutely huge, 1/2 metre in diameter as I said. So a few lessons learnt. The original faceplate piece I printed on a completely cold bed, and it's come out fine, all the overhangs are fine. The only issue is the bottom isn't quite flat, and the reason for that is there's been some warpage in the part as the layers have shrunk. So even though I printed them in PLA, there's still some shrinkage as the plastic cools. So the large side parts I did with the heated bed on at about 60 degrees, and they've come out with a much flatter bottom. There's a tiny bit of warpage, but obviously they're much bigger. The bottoms aren't too important on these pieces because it's the bottom. Where pieces stuck together, it's far more important they're flat, however. So this is the one I had the problem with the overhang on, and then I slowed down the printer, if you remember, to about 60%. Again, I used the heated bed and that overhang's come out fine. When I moved on to do the top of the helmet, basically I used the heated bed on this side, so the bottom's fairly flat and the part hasn't warped too much. But again, I basically had a problem with an overhang and I forgot that was there, or I would have slowed the printer down. So when I came to print the other half, I decided I'd just try it without the heated bed on and see if that made any difference. So the overhang is much better, but the bottom on this one's absolutely dreadful. It's basically really curvy, and I've already tried to sand it off to make it flat, which is practically impossible. So I then reprinted that again with the heated bed on and slowed the print right down to fix the overhang. And that's much better, those fit together. There's a tiny bit of warpage that's going to need some filler on, but it's much better than this one, which doesn't fit together at all. There's a huge gap at both the top and the bottom. So I guess the lesson learned is if you're printing large parts, use PLA, use the heated bed if they're really big, but watch out for those overhangs. So these things are going to need to be filled in. Similarly, there's some tiny gaps where these pieces stack on top. So I'm going to be using some standard car body filler which is P38 and other things in the UK and Bondo in the US. And I'm going to be gluing all of these parts together, or at least the tops on these, and the two halves of my helmet top together using Gorilla Glue, which also expands to fill gaps. So I'm expecting that to expand out and fill out the cracks, then I'll sand it off. And eventually I'm going to be coating all these parts using Smooth On XTC 3D, which is a special coating for 3D printed parts. But that's going to come in another specific video about this. I haven't even got this out of the box yet, so I'm not going to try and cram that into this week's video. I'm going to do a separate video. So let's get some of these parts stuck together. So most of my parts have been stuck together with some glue, so that's expanded to fill the gaps. I've got a bit of clean up to do. We can get our first idea of what the whole thing looks like together, very approximately. So it's looking pretty awesome, and in a moment I'm going to temporarily attach these pieces and stick it on top of Hulkbuster. So for now we need to clean this up. There's still a few gaps that need to be filled in, so let's get on with that. So I'm just going to use a knife to trim off the bits where the Gorilla Glue has expanded into the gaps. So it's pretty easy. Some of these I can probably snap off by hand. There we go. It's pretty tough stuff, but it basically expands into foam. There's a few more bits on the top there. Just need to trim those out. Then we can sand those off a bit better as well. So I'm using P38, which is a car body filler. You can buy Bondo and other brands. So this comes as a base product and it comes as a hardener. So you mix the hardener and the base product together and it makes a paste which you then put in the gaps and it fills them and hardens it. This is based on polyester resin, which you should use in a well ventilated area or technically for a respirator. And it's got talc in that makes it into a paste and it's ready mixed. So all we need to do is squeeze out a line of this stuff, and you don't need very much typically for these sorts of cracks. The normal practice is one line of that and one line of the hardener the same length, which comes from a smaller nozzle. It's approximately right. It might be a bit too much. And then we mix them together till it turns pink. So I've just got some sticks here, and actually comes with a thing for applying it, but I've got some different flexible bits of plastic. Just keep mixing it till it's consistently pink and there's no streaks in it. It'll start to go off, depending if you put more hardener in, it will go off sooner. So now that's pink, I should start bodging it in. So I'm just going to put that into all the holes, like so. So I've already filled in that dodgy bit of overhang there and sanded that back down. So I'm using a combination of sandpaper with a bit of wood, that, and some needle files. So it's quite dusty stuff. It sands really easily. Obviously don't breathe in the dust, use a dust mask. And I've got a vacuum cleaner here so I can regularly go and suck the dust away, but even this pad will take it off quite easily. So we just need to sand over the seam lines. Any sort of harsher bits we can use the stick like that, so we can just take off the excess and we can sort of spot sand any blobs and just take that back so the seam feels nice and smooth. So here it is on top of the suit. The first observation is it's really big. Obviously it's not in quite the right place. It needs to go back slightly more, and it's actually going to sit slightly higher looking at the mechanism that I've already built. So let's just come a bit closer. Doesn't look too bad from up here. And there we go. And if we come around the side here, I'm just going to precariously climb up on something. You just about see the mechanism inside there for the two side hinges, and the top there comes almost in the right place, but there's going to have to be an extra hinge that flips down that top of the head plate as it angles over the runner, which is still fitted in here. I'm not too sure if it's too big. I looked at pictures of other Hulkbusters and they kind of look the same kind of width. I guess it sits a bit high. Maybe it's that the arms are too thin. Maybe if I get them and do this. I'll do this, you tell me, how does it look? How does it look like that? Does it look okay? There's going to be some adjustments to the arms, I think. Maybe to the shoulder bells. Maybe there's some other internal bits. Maybe I'll just burn it in a fire to celebrate April the 1st. In any case, that's all I've got for this episode, so don't forget to subscribe to my channel and check out the other projects. There's some Star Wars projects and Alien projects and some other stuff. And also some regular product reviews and unboxings.